I've been in the software industry for a very, very long time. And things are interesting about me is I joined X.com in the very, very early days. Even before it merged with PayPal, I was hired by Elon. And I built many of PayPal's core infrastructure components. I thought I should mention it since I'm talking to a payments company. And I built the system that balances PayPal's books. And I hear that it's still in use. So it's pretty cool. That was 15 years ago. And then after that, I came to YouTube. And one of our greatest exciting things that happened at YouTube was we managed to succeed in sharding, which we did not succeed at while we were at PayPal. Hold on. So that's my background, and we started this Vitess project about 6 years ago. So we've been at it for 6 years, and I think I have a slide for that. So I'll cover the details about what we did. And what else? I do have a blog. I don't blog much, but whenever I think that I find something earth-shattering, I do write about it. In particular, if you go there, you will see some revelations about Paxos, about replication, and about reparents, durability. So those are things that I'm pretty excited about. So you're welcome to go take a look at it. So this is what we are going to cover today, a little bit about what Vitess is, what it can do, what it was built to do, and what it can do for you, and if you're interested, how to start using it. So those of you who have no idea what Vitess is, it's basically a system that helps you scale MySQL to a very, very large number of nodes, and basically indefinitely scale MySQL without having to worry about an end for it. It has 3 components. One is handling queries. The other is sharding and resharding. And the third one is basically managing your cluster. Those are the 3 areas that Vitess helps you with. And how was Vitess started? Back in 2010, YouTube was growing very, very fast. And we were actually having trouble keeping up our MySQL databases up. Actually, every time there was an outage, it was always a MySQL problem. And it was becoming completely unmanageable. So the 2 of us, myself and Mike Solomon, said this is not a happy place to be. So what we actually did was we took ourselves out of the day-to-day rotation, and we said we are going to go and meditate about this problem, and think about how we can leap ahead and come out ahead. And Mike actually built a huge spreadsheet. It was like 10 pages of just problems that we've encountered, and then what we can do to solve them, what we can do to mitigate them. And when we put all of that together, we realized that there are common design elements that can be used to solve a whole category of problems. So that's basically how the Vitess design was born. And then we decided, it was a very selfish movement. We said, if we are going to do anything about this, and we end up leaving YouTube, we don't want to ever rebuild this again. Right? So we said, we are going to open source this. And Google is an open source friendly company. So when we asked for permission, they said, yes, it's fine to open source it. So that's how Vitess became an open source product. But it wasn't easy because YouTube runs at such a large scale that every problem you encounter is very specific to YouTube only, right? And when they come and ask for features, they say, oh, you need to solve this problem. But then how do you solve it in open source for YouTube, which has a very specific problem, right? So we had that challenge all the time. But we resisted the urge to patch anything in, to hack anything in. We say that no matter what problem comes, we will find a clean design for that and implement it in the open source. And then we import it back into YouTube and deploy it. So it was challenging, but we managed to keep that discipline. So Vitess has remained a fully open sourced software. Even today, primary development happens in open source. Any feature that comes in first goes into open source, then we import it and build it at YouTube. So initially, many of the features were very specific to YouTube, but over time, those became more and more generic. So many of the features that we built, that we have built recently are very generic features. Some of them are not even used by YouTube. But one challenge is that YouTube, as you know, is a huge QPS company. So any code that we wrote had to be production worthy. So there was no such thing as trial period and stuff, right? Experimental. So we would build experimental stuff, but we will hide them behind the flag. But when we turn it on, it had to be production ready. It had to take the huge QPS that YouTube generates. That actually is the reason why Vitess took 6 years to mature to the point where it was, because a large amount of the work was actually making Vitess, keeping Vitess production ready. And even today, we import from the master branch and deploy. So that's basically how Vitess works. We don't have release branches. We do have a release branch, but it's more for our users, not for ourselves. And the biggest victory point for Vitess is that now we have scaled to a very large amount, probably in the thousands of servers. But our operator overhead is still O of 1. There's still just one person that goes on call, and they hardly ever get paged. So that's like pretty exciting. And Vitess has an active engineering team, so we are constantly adding features. And as you would notice, you'll see that all the newer features are now to satisfy the new users that are coming on board to use Vitess. There's not as, like YouTube is very, very happy with what we already have. So this slide talks about what would a company go through if, as it grew over time, right? So when you start off, it's always very simple. You set up a master database, throw in a couple of replicas, and you're off the mark, you're serving queries, everything is happy. This is the happiest place you would have probably been when life started. It's all downhill from here. So obviously you can take this architecture pretty far because once you add replicas, you can just keep adding more replicas to scale your reads. Usually when the writes become a bottleneck is when you find yourself up against the wall, and then your only chance is to actually perform some resharding. And usually you don't reshard right away. You usually split your database into smaller databases. We call it vertical splits. Take some tables out and have multiple databases. And then eventually when a single table becomes too big, you're forced to actually split it horizontally. So, and this actually is a step that most companies can do without too much trouble. But the problem is not the fact that you can do this. The problem is that it is hard to keep this going. As your things grow, this becomes gradually unmanageable. And you're already started paying some price on the fact that you've done this. You've lost transactionality. Cross-shard queries are becoming a problem. And your application has also become more complicated because it has to be shard aware now, because it has to know where to send a query, when to send a query to all shards, and all those complications come into play. And over time, that complexity actually feeds into everything else that you build in the application. And new problems come up. As you scale, more and more servers are coming up, so managing these servers is becoming a pain. Hopefully, you're growing fast enough that you have now clients that are across the world. You want to have servers that are nearby. And somebody throws this two-letter word called DR. It says, oh, what do we do about disaster recovery? And then all hell breaks loose, usually. That's around the time. I actually say that that's a very good time to make your resume. So anywho, so we survived that. You then add multiple cells, and then it's now you have a farm of databases. And at this point, if it hasn't been thought through, at this point, resharding is almost impossible. Because how do you manage resharding when you have replicas thrown all across the world, right? So that's basically where Vitess will come in. But along the way, there's a couple of other problems that you might have seen. MySQL is not very good at handling new connections, so connection count becomes a problem. And there's this thing called toxic queries. There are these people called engineers that write new queries all the time. So even if you have like 100 engineers, very sharp, and each one of them makes only one mistake per year, right? That's still 2 issues per week that you're seeing. So you want some protection at the system where if something goes wrong, it doesn't take the whole system down. So those are some of the new problems that I assume you would have all encountered. And so basically what Vitess does is helps you along the way, make this journey easier. It basically, you start off with a simple database, but as you scale, Vitess takes away that complexity and keeps it within itself. So that's basically the goal of Vitess. And I will run through this kind of a little bit quickly because I want to make sure that I finish and have enough time for questions. So when we first built Vitess, it was actually not to handle sharding. It was actually to handle connection pooling and toxic queries, because those are the things that were killing us, right? So those are the early features that we built of Vitess. So connection pooling, now we have, Vitess has connection pool for, separate pool for queries, separate pool for transactions, and separate pools for streaming. And that actually helps you manage overload anytime it happens. It always is contained to one part of the system. The other cool feature that we built, which may or may not be applicable to a payment company like yours, which is if 2 identical queries hit the system, which is very, very common for something like YouTube because the video is popular or a user is popular. That used to take our system down all the time because there's 10 such expensive queries hitting the system at the same time. Now what Vitess does is that if anytime it sees duplicate queries, it sends only one to MySQL and then shares the result with all requests. So that has actually saved us so often that now it's a core feature. And we don't even, earlier we used to chase down engineers saying that, well, don't do this, don't do this. Now we don't even do that because Vitess automatically protects you from it. And there's, we also rewrite queries. We were a statement-based replication shop, and replication was expensive. So Vitess used to rewrite those queries into primary key-based updates, and that makes actually replication as efficient as RBR. A lot of protection that we built, if you are in an OLTP thing, things tend to grow pathologically. Sometimes a user suddenly has a million transactions, or in our case, a user has a million videos. You don't think that somebody should have that, but then it happens. And the app thinks that, oh, this is only 10 rows, but suddenly you get like 10,000 rows, right? So you can, so what Vitess will do is that anytime you send a query that's unprotected, it'll put a limit clause on it. And then if that number is exceeded, it'll say, sorry, you were asking for too many rows, please go rewrite your queries. Yes, that query will constantly fail, but it'll protect the rest of the system. It'll keep the rest of the system running without taking the entire database down. So we have a sophisticated limit system. You can put time limit on queries, time limit on transactions. You can blacklist queries. We've also added ACLs because there was another ask. So basically, all these features you get for, these features were tuned over time for YouTube, and we believe that they are useful for any company that tends to scale very high. And we also had built a large number of troubleshooting tools. At this point, our troubleshooting is so good that we rarely have to go inside MySQL and look at it. There is like what Vitess reports in terms of query performance has always been sufficient for us to get to the root cause. Usually, if there is, if CPU goes up or if query latency goes up, the graphs immediately tell us that it's this particular table, it's this particular query. It shows up immediately. So it's almost, we actually don't use DBAs at YouTube anymore. We use only standard SREs. They perform SRE type work to maintain Vitess. And we have other sophisticated tools where if you want to do deep analysis, we give you a live query log where you can log everything and then run some MapReduce on it to analyze query patterns, efficiencies, and stuff. So, and also troubleshoot. Status pages. So it's really very refreshing to use YouTube. That's what our users are telling us. But the biggest new features that Vitess has is transparent sharding. Is that now, if you have an unsharded database and you decide to reshard it, you do not have to rewrite your application much. Maybe a few queries that are pathologically bad, but mostly your application can run as is because we have built a automatic routing mechanism that understands your queries and knows how to route it correctly. It can do joins, and there is a DB compliant API right now, which you can use. So instead of using the MySQL driver, you use the Vitess driver, and most of your queries should work as is. People have asked us for a MySQL protocol, so we are thinking about implementing that so that you don't even have to point it to a driver, you just point it to Vitess. We have some big data. This is actually used extensively within YouTube. People tend to run MapReduces against MySQL itself. It's something that has never been heard of, but we do it all the time. We figured out how to make it work, so that's something that Vitess has. And resharding is actually the best part of our story. There is a picture of us when we did our first resharding. We were all holding our wine glasses, celebrating picture and everything. But now resharding happens all the time. We don't even talk about it. There's not even an announcement that goes out. The last email from our SREs was, the last resharding was completely boring and uneventful, the way it should actually be. was how it happened. So we don't send announcements to engineers anymore. I mean, we do send announcements, but it goes to the spam folder because nobody cares. So that's how smooth resharding has become and how mature it has become. What else? There are cluster management features, some of which actually we use, some of which are only for open source. You can like when the fleet is deployed, in our case, databases go down all the time. Replicas go down, masters go down. When that happens, the application doesn't know anything. It just talks to this proxy called VTGate, and VTGate knows what is up and what is down and appropriately routes queries. It performs load balancing. We have workflows for backups, restores, reparenting, replication, etc. There's a whole bunch of things that Vitess can do for you. But one thing important is that it is a la carte, which means that you may or may not need these features. If you don't need these features, you don't have to use them. But there are specific ways we perform it. So if you want to use these features, you may have to enable you may have to run MySQL certain way, like using statement-based replication or GTIDs like we have designed it for now. Before I exit this thing, this is kind of somewhat of a marketing slide. If you ask, like, where does Vitess stand in the market? Like, what kind of storage system is Vitess? The best way to describe Vitess is that it's the NoSQL storage engine. So on one end of the spectrum, you have relational databases, which are hardcore, consistency-oriented databases that give you all kinds of data guarantees. And on the other side, we have NoSQL databases that are extremely loose about their guarantees. Vitess actually tries to get the best of both worlds. As you can see, what you lose from a relational database is you lose some ACID guarantees. That becomes basically what NoSQL databases give you, which is eventual consistency. But if you look at if you come from a NoSQL to Vitess, you will notice that you actually don't lose anything. Vitess addresses many concerns that NoSQL databases have, but doesn't have any other cons. And that is an important note. Actually, Vitess is used as a key value store, and it kicks butt. So there's a lot of people who are very happy with Vitess as a key value store. So that is something that you can think about. What else? And the thing, this slide actually doesn't do justice to Vitess because There are many other NoSQL stores, but what makes Vitess great is actually its architecture. In today's world, if you think about sharding, people always say, what's the first question that pops up when you say sharding, right? Say, what's your sharding key, right? That's a NoSQL question, right? If you want to shard a relational database, that is probably the wrong question to ask, because when you shard a relational system, you're sharding a system that is much more complex than a simple key value store. So the questions you answer actually are more complicated. So basically what we did was we actually rethought sharding from the ground up with respect to a relational database, and I'll cover that. But that is actually what makes Vitess architecture unique and awesome, in our opinion. Just to give you a overview of, so far it's been all cloud talk, right? These are actually the components that Vitess has. The way Vitess works is that you have your MySQL instances. You deploy this server called VT Tablet on top of every MySQL instance. It attaches itself to MySQL like this and takes full control over it. And then after that, all queries go to VT Tablet, and VT Tablet decides how it should rewrite that query or send that query to MySQL. For example, if a query takes too long, it'll kill it. So it watches over every query that it sends and makes sure that MySQL is healthy underneath. And VT Tablet also performs many of the housekeeping work, like if you want to take backups and stuff, then VT Tablet does that for you. So every MySQL instance has one VT Tablet. It actually is in the same machine. It attaches itself using a socket, and so it's one unit. It becomes one unit. We call it the tablet server. And outside, we have these VT gates, and they are actually stateless servers. You can deploy as many as you need, and so it's fully horizontally scalable. VT gates can go up and down, no problem. You can freely kill them. Nothing will get lost if a VT gate dies. And the transaction management happens through a cookie-style communication. And so the advantage is that when a request comes to VT gate, it will decide, VT gate is in touch with the topology, where it has a list of all the servers. And then when a request comes, it checks the topology, finds out where the master is, and then sends the queries to the master, to the replica, or if there is a streaming query, it also sets up the stream for you. And on the left-hand side, the app server doesn't need to know any of the details that are inside. It just connects to one of the VT gates and sends the queries as if it was just a simple database. So the two components that we have is the topology, which is either a zookeeper or etcd. We have actually an interface that we have built, and internally we use zookeeper. Chubby. I assume some of you have heard of that thing. So we use Chubby internally, and outside it works with etcd or zookeeper. And VTC TLD is just a dashboard that helps you look at what's going on. You can also perform housekeeping operations using VTC TLD. Any questions so far? All good? OK. Resharding. I could spend half an hour just talking about this, but let me try to explain it in 5 minutes. So the way we do resharding is every row that is in your database has the key space ID. The key space ID is the same as your sharding key in a key value store. So you say this is your sharding key, and there is a column for that. It's a lie, but assume that there is a column, which is called the sharding key in a database row. So that is the core thing about Vitess. And we actually range-based shard based on that key. And then what we do is, just like in a database you can define indexes, you designate other columns in your table as indexes, as sharding indexes. What that means is that you say this column is a sharding index, which means that there exists a mapping between this column to the sharding key. You say that it can be either a functional mapping, which means that you apply a hash and then you get the key, or it could be a lookup-based mapping where you say you go look up in a table and it tells you what the key is. So it works just like a traditional database index, where you have a column value, you go to an index table, and it tells you what the primary key is to tell you where to get the row from. So these indexes are basically, as Jiten says, is one level of indirection above the sharding key. So what that gives you is the ability to actually define how you are going to shard, because the function says I'm going to do hash-based sharding, or I'm going to do mod-based sharding. Right? So you can make those decisions independent of how Vitess lays out the data. So that's one advantage. And the other advantage is that you can designate multiple rows in a table. So you can actually have multiple indexes, or Windexes as we call it, Vitess indexes, for a given table. So if you, actually I've been talking to John Terson from Sweden. So he's been talking about order table where there's an order ID and a customer ID. And you could have the option of saying that order ID is a sharding key, customer ID is also a sharding key. And so one of them will be hash-based, will tell you, which immediately computes. The customer ID would say, you hash the customer ID, you get the key space ID. And at the same time, you build a lookup table from order ID to customer ID, which will be your secondary key. So basically, you get cross-shard indexes. So you can build, and you can build such powerful relations. Basically, your relational database, when it scales out, remains a relational database, unlike a traditional key value store where you can only go through one sharding key. And because it has the same parallels of an index, it can be non-unique, which means that you could have a customer name that may be non-unique, but you may still want an index saying that I want to search all customers by name. You can build a sharding key that's non-unique, and that will also work. It takes a while to understand it, but it's really, really powerful and flexible. And now, to undo the lie, the requirement is that one of those indexes has to be unique. If you have multiple sharding keys, one of them is unique. What that means is that that index will yield only one key space ID. And because of that fact that of this restriction, there is actually no need for a physical key space ID to be there in your table, because it's always computable based on the primary index of a table. So therefore, there is no need for an actual physical sharding key in Vitess. The best way I describe it is the primary Windex is kind of your sharding key, but the sharding function is defined by you. And we've gone beyond this. We actually, some of these lookup tables can be shared across multiple tables. Like, for example, if you have an order ID, if you have an order table, and if you have an order detail table, right? You want those rows to live together. And the lookup for those actually is the same mapping that the order table uses. So you can actually reuse this. So that kind of acts like a foreign key of a traditional database. And the best of all is the Windex is actually a formal API, and you can define your own. So if you already have sharded a certain way, you can actually port that sharding function into a Windex, and Vitess can take over that from then on, and then the application can throw away all its code about how to route a query. And not only that, once you've done this, you can reshard underneath afterwards, because Vitess knows how to work with your Windex for resharding. So very excited, because that took us a long time to get right, and I think we got it right. So we can route. Once you have a Windex, you send a query with a where clause that addresses the Windex column, then Vitess will know, oh, yes, I know how to compute the key space ID for this column, and then I know how to route the query. It knows how to perform joins using Windexes. There's actually a 50-page document that I've written. You are welcome to go and read it. It's published in the open source thing that describes the theory behind how this routing works. On the back end, if you perform resharding, the same Windex is used to figure out how to split your database. So it all comes together. Very nice story. The other, before I get off, the final punchline here is there are lots of new databases that are being built, like NoSQL databases. But the common architecture is that they actually, at least the ones that I know of, they build a key value store, and then they build sharding on top of it. And then they build the SQL engine on top. The problem with that is that if you perform any query that is beyond certain level of complexity, all the rows have to be pulled out of the leaf nodes into the SQL engine to perform your work. And that, I think, is not a good architecture. The good architecture is the one where you can push all the work down to the leaf nodes. And that is another thing that we got right, but it was pure luck. But we still take the credit for it. So in our case, if a query comes, the first thing that VTK tries to do is, how much of this work can I push down into the MySQL? So it tries to outsource as much as possible, push as much as possible down, and only what is left, it just ties together just to return the results for you. So it's very powerful, very efficient, and very fast. So that's what we get for that. And in terms of users, obviously, we have YouTube. As you know, YouTube does exactly 1 gazillion QPS, where gazillion changes over time. I'm not allowed to talk about real numbers. But I can talk about when we started, we had when we first launched in 2011, we were doing about 200,000 QPS is what we were doing. And we were saying, oh, wow, hundreds of thousands of QPS. And then we say, oh, I can't wait for the day when we'll do 500,000 QPS, when we can do 1 million QPS. So as we started growing over time, what happened, something strange happened. We lost interest in our QPS numbers because it was immaterial. Because at this point, literally, we can do any amount of QPS. So why does it matter, right? 1 million, 2 million, 3 million. Whatever QPS you can throw, no problem. So we are actually now focused on making Vitess more interesting functionally. So that's actually what we are focused on, because QPS is a solved problem for us. Flipkart was the first early adopter that came to Vitess, and their statement was, there is nothing like Vitess out there. They have looked at all kinds of other systems. They have actually migrated out of other systems into Vitess. They think that Vitess is about 4 or 5 years ahead of the rest of the market in terms of sharding relational databases. And Stitch Labs is a recent customer. I shouldn't say customer, it's a user. They're not paying. Is a recent user who also actually migrated from something that they licensed, and they say they are also super happy with Vitess. And there's more users coming along. Square is actually giving it a good shake. I've been working with John at Sweden, so we wake up in the morning and chat a lot. And John Terson and John Cesario here too, that I chat with. There's many other customers. There's Nozzle, there's Better Cloud, a few other customers that are pretty serious about switching to Vitess. Why should you use Vitess in general? Why should any company use Vitess? Is basically sharding. When you come to a point where you say you need to shard, sharding always looks easy when you take a first look at it. But the problem is that it doesn't remain an easy problem. It's a problem that grows on you and becomes worse over time, and the pain continuously increases. And so even though it looks easy now, it's not going to remain easy. So therefore, don't try to do your own sharding, is the first piece of advice. Vitess is battle hardened, so you don't have to worry about its how solid it is and how stable it is. Cluster management also gets progressively harder. Just because you think you can solve today's scale, things become exponentially worse as you add more servers somehow. Vitess, we have, that's actually where most of our effort was spent on Vitess, is to keep the operator overhead constant, not to require more people to be hired because you're adding more servers to your system. And the cloud is coming, whether you like it or not. Sooner or later, somebody is going to ask you, how about Kubernetes, how about Docker? And Vitess was built to live in that environment. So if you use Vitess, it'll be very easy for you to migrate into a cloud environment. As far as the team is concerned, we are about 8 people, but you are really, really passionate about it. When we built Vitess, we were mostly focused on cleanliness of design, doing the right thing, doing the right way. I mean, we always wanted people to use it, but we didn't completely believe that that was going to happen. But suddenly it's happening. People are starting to use Vitess, and that got us like really, really excited. We said, oh, wow, it's not just YouTube. It's like others can also use this. So that part is exciting. And we are very committed to keeping open source viable. As you would see, we have a Slack channel that's quite active. And at this point, we are prioritizing all immediate needs and blockers that users are having. So the way you should never ask, does Vitess do this? You should ask, can Vitess do this? And the answer is probably yes. So that's the state we are in. If you want to migrate to Vitess, this was actually a special request from the ops team. How would you, if I have an existing database, how do I migrate to Vitess? People have used different strategies. Stitch Labs used the offline strategy where they brought their database down, performed the migration, and brought it back up on Vitess. And they've been happy with that. They did that like one shard at a time. So now they are fully on Vitess. They do about like 200 to 250,000 QPS on it. As I said, it's no big deal. And there is another, Nozzle is a company in Utah. They are planning to do dual writes, which means that they are going to bring up a parallel system on Vitess, and they are going to do dual writes. And they are going to validate the two systems with using dual writes. And at some point of time, they're going to cut the old one loose. The way we did at YouTube is we deployed on top of our existing setup. So MySQL servers are running. We just deployed Vitess on top without touching any of the MySQL servers. And we shifted traffic back and forth between Vitess and MySQL directly. And over time, we basically completely migrated to using only the Vitess API. And then after that, we shut down. Our MySQLs don't listen on ports anymore. They only listen on our Unix sockets because we don't directly ever connect to MySQL. So that's how we migrated. So there's basically various migration strategies, and they all make sense depending on your needs. In terms of consideration, if you look at the launch document, Vitess says that it requires statement-based replication, GTIDs, semi-sync enabled. It needs multiple replication servers. It needs RD-only setup. So these are things that we say we need, but these are things we need only if you plan to if you plan to use all the features of Vitess. Depending on, for example, if you say, oh, I do my own reparenting. I don't want Vitess to do it. No problem. Vitess can work with that. We actually, even internally, Vitess doesn't use its reparent. It actually uses an external tool to handle reparents. So even within YouTube, many of the features that Vitess has, we don't use because things work differently inside Google. Same thing with our users too. So depending on what your needs are, if you so basically Vitess can be deployed on your existing setup without disrupting anything else. as long as, but if you want to use more and more features of Vitess, some of these things may have to be enabled. And the other option is you can tell us saying that, well, we don't want to get away from row-based replication. Can you make it work? We probably can. We just haven't had to do that. So that's always there. In terms of roadmap, there are some big features. The biggest one is 2PC. 2PC is another half-an-hour talk that I can give. As you know, you may not know, MySQL supports the XA protocol, which is a big disaster. It's basically unusable. It's buggy. Don't ever use it. Don't touch it. Don't go near it. But what we have done is there is actually a blog about how to implement 2PC on a system that doesn't support the XA protocol or the prepare protocol. And so I published a paper that was validated by all the experts of the industry. They said, yes, it's solid. And now the implementation is actually almost done. So it'll be out in a couple of weeks. So, and the important thing is that 2PC has failed in the past. Nobody uses 2PC in the market because of how it was implemented. So I believe we have identified what they got wrong, and I believe we have addressed those concerns in the new 2PC implementation, which means that 2PC should scale for anyone that wants to use it. And it's important, like especially when you are going to have these lookup databases, these lookup tables that live in other databases, and you are now performing updates that are cross-shard and cross-database, you want atomic transactions. And that is something that 2PC will solve for you. We do want to support row-based replication. That's very important. We want to support MySQL protocol. A lot of people have asked for it. And a whole bunch of other features that are coming. But more importantly, is there something that you would like us to do? We'll be very interested. So, and that ends my talk. We have 10 minutes for Q&A. Thank you.
Why the name Vitess?
Oh, that's a good story. So we originally named the project, the original name for the project was actually Voltron. And we started with Voltron, and then all our file names, class names, everything was VT this, VT that. And then finally, it was actually an internal repository. And finally, we said, OK, we want to open source this. I think I said, you can't use Voltron as a name. Come up with a better name. And so we had to find a name that rhymed with VT. And so Vitess was a name. It stands for speed in French. It was like, by the way, when we came up with the name, Vitess was actually very, very slow. It was like, it was using Go 1.0, which was like, the garbage collector used to take like 5 seconds to, I don't know, you used to have huge pauses. But we believed that that will be fixed. So we named it Vitess for speed. And I don't know how many of you know about Strong Bad, the cartoon? Never heard of it? Yeah, Homestar Runner. So he has advice about how to name products and companies, where you say you take a very common name and completely misspell it. So I followed that advice and dropped the E. And that's how Vitess came about. Yes?
So what happens in practice if you have an active sharding strategy and you decide to change the index? Like how does it actually act on that?
Yeah, so if you already, like what kind of, is it a mod-based sharding strategy? What is the, how do you map your column value to a key?
Imagine like you started with a simple hash and you realized it wasn't good enough, so you switched to a lookup table.
Yeah, so let's say you have the original value and you have a hash. And how do you, so is the hash range-based? Okay, so if it is range-based, that's one question. The next question is, the hash is unique per sharding key, right? So you basically have a big range of values on your target database. Do you have a physical column for it? Yes, yes. Yeah, so we, the way, if the way you solve that problem is you make that shard smaller. What you could do is, we do range-based sharding, but the ranges are not uniform. So you could actually have a large range for less active rows, and you could probably dedicate one shard for just that hash value. So that is how we say you solve the problem. But you may want to rethink your sharding strategy entirely, right? You may say, okay, maybe this is not a good sharding column. That's a feature that we want to develop, which is, I call it the regret feature. So I regret sharding by this key. I would have been better off had sharded by that key. So we plan to implement that feature where you say, okay, reshard the entire system using this other key. So that will come soon. But for now, what you can do is Vitess ranges don't need to be uniform. As a matter of fact, the Stitch Labs, they have actually a map-based sharding, and they have this hot row problem because they are a customer-oriented system where they have one customer that's really, really big and some that are small. So they actually have extremely non-uniform shard ranges, and they are pretty happy with it. The thing is that once you move your hash, once you port your hash function into Vitess, then afterwards, the resharding then happens completely transparently, because then you can split and merge. Vitess allows you to merge shards also, by the way, so it's not always splits. So you can split and merge as you need afterwards. Yes?
I have a question from Zellen Hunter, who is remote right now, and he asks, what do you think about cockroach DB?
Oh, oh, or what do I think about Spanner? So I would say Cockroach DB, this is based on what I actually don't know much about Cockroach DB, but I know a lot about Spanner. They are actually systems that have different guarantees. Vitess is all about speed and performance. And Spanner, which I assume would be same as Cockroach DB, is all about consistency and durability. For example, in Spanner, if you write data in one place, that transaction isn't complete until the data is replicated to 2 other data centers, for example. So there's a price to pay for that, which means that your writes take 50, 100 milliseconds to complete. So that's kind of the price you pay. But Spanner gives you the awesome guarantee that we will never lose your data, even if it's the end of the world. Right? So that's the kind of guarantee you get from Spanner. And you can also, I assume Cockroach will also have these things where they give you strongly consistent reads. But there's a price to pay. You can get that, but I don't think if you have a speed race between Vitess and Cockroach DB, I think Vitess will just kill. But if you start like completely nuking data centers, you'll probably lose data with Vitess. So that's high-level difference.
Internally at Google, what's the adoption rate of Vitess versus things like Spanner and Megastory?
Yeah, that's an embarrassing question. So the way we work is Spanner is kind of internally recommended at Google. So anybody that comes to Vitess, we ask them, have you looked at Spanner? Why aren't you using Spanner first? Why did you come to us in the first place? And if they say, well, yes, but we still want to use Vitess, then you say, okay, then use Vitess. So that's there are some people that have chosen Vitess in spite of Spanner, but it's only after we've heavily discouraged use, told them you should be using Spanner. Why are you coming to us? And they still came to us, so we let them use it. Yeah. Yes. Oh.
What is your general approach to deployment on AWS?
Right now, I think there is one user that is deploying on AWS. They are using S3 for backups, but it doesn't work on RDS yet. We definitely want to do that. They basically spin up AWS instances, VMs and containers, and they run stock MySQL on them. And I don't know the name of the user. I think it's probably HubSpot. I could be wrong. So they are running on AWS, stock AWS. So far, they don't seem to have encountered any major problems. But somebody asked about RDS, and when I looked at it, it didn't look like it would run as is. We'll probably have to make changes to Vitess, but we want to make that happen also. Yes.
Can you speak to like the maturity of like language for the driver?
Oh, so right now we have 4 native drivers: Go, Python, Java, and PHP. Yeah. Somebody asked for Ruby, somebody asked for Perl, but nobody in our team knows those languages. But Vitess runs on gRPC, and there's client support on all languages. So all you have to do is write 100 lines of code. Yes. You after him. Yeah.
So I guess how complicated are the clients themselves? I mean, are they mostly just wrappers around gRPC, or would it actually be a lot of effort to say maintain one in Ruby?
Oh, it's very, very little. I would probably say about 100, 200 lines of code per client. Just a wrapper, yeah. There's even a design guideline for you to follow about how to write a client. Yes.
I'm curious about the commodity hardware that you have at Google.
Oh, yes, yeah, yeah.
What do you mean by that, and how much homogeneity do you need?
Yeah, that's actually something I did not cover here. It's a very good question. We love small shards. I can't begin to tell you how awesome micro-sharding is. The standard recommendation that we give is like don't make your database bigger than 100 gigs, because as soon as it starts to exceed that amount, MySQL starts to fall apart slowly, gradually. You can go to a terabyte, you can go to 2 terabytes, but things get painful, painful over time. And the advantage of running small shards is your backups are almost instantaneous, your restores are almost instantaneous. Struggles to keep up, right? And so and MySQL wasn't built to use 48 cores. It has all kinds of internal locking features. Even the buffer cache, it can't use the buffer cache beyond certain size because the locking contention that it experiences. The way MySQL solves it is they make you deploy multiple buffer caches so that there is less locking contention. So all these problems actually go away if you go smaller. So that's one part A of part 1 of your answer. Part 2 is the way the only downside of commodity hardware is the fact that instances go up and down all the time. And that affects your durability, which means that if a database goes down and what you committed there has disappeared, then you've lost data. And the way we solve that problem is using semi-sync replication, which means that a transaction is not committed until a replica has received that data. So in our case, we never lose data because when a master database goes down, there is a guarantee that somebody else has it, so we can always reparent to that replica. So using these two, we have a really consistent and beautiful scalability story for Vitess. Yes?
Given all these guarantees, what is the implication on query latencies?
Yes, so the way we budget it is based on what we have seen. It's about 1 millisecond per hop. So I would add up to about 2 milliseconds additional latency on an average. It's a very broad thumb rule per query. So that would be the general cost. But of course, it depends on data size. In YouTube case, like the servlet still performs multiple round trips before serving the data, and we are not the problem at this point. I don't know about you guys. It could be different in your case. Yes.
Hi. First of all, ODS completely loves the 100 gig idea. And I also have a question from John Pongman, and he has a question. I don't totally understand this question. His question is Vitess on the Google storage roadmap?
Is Vitess on Google storage roadmap?
Totally understand. So I think it's with Andrew Fikes. That's just
Oh, yes. Not right now. So we are talking to that team, and we are trying to convince them to make Vitess also part of Google's roadmap. But at this point, the answer is probably not. So it's at this point, Vitess is a YouTube product.
100 gigs.
100 gigs, yes, yes. And we recently did a micro sharding where we went to, where we now have hundreds of shards in one of our databases, and our SREs couldn't be happier. Yes?
If you're doing a write, putting data in multiple shards, what are some of the ways that that write could fail and leave inconsistency in global state?
Yes, so if you used Vitess today, you would have partial commits. But once 2PC is ready in a couple of weeks, for writes where you think that the write has to be atomic, Vitess will give you the guarantee that either all those writes complete or none happens. So that guarantee you will get. To some extent, to the extent where it's practical. I mean, if something catastrophic happens, there could still be situations where you may get incomplete writes, but it's almost impossible to make that happen. You have to do something very, very drastic. So with semi-sync, using semi-sync replication, if you use 2PC, it'll be very hard to lose writes, to end up with partial writes. But there is a price to pay. So I would say you should still use that feature with care, because guaranteeing that something has to be atomic across databases has its overheads, because you have to save the statements, you have to be able to replay them on a new master. So all that mechanism is in place. So that does have a price. But if you really, really care about atomic writes, you can have it. Cool. All right. Thank you very much.